Let's look at impulse and safety considerations. Knowledge about impulse is applied in real life to improve safety and reduce injuries. Remember, if the change in momentum is constant, net force is inversely proportional to time. That is, for the same change in momentum and a greater time or a greater change in time, the net force on the object is smaller and less damage occurs. Right? Remember that we said F net is equal to change in momentum over change in time. Right? So if the denominator increases, it means the value of this whole thing decreases. If time increases, then F net decreases. If time decreases, then F net increases. Okay, right. So this principle is applied in car airbags, seat belts, arrestor beds, crumple zones in cars, and then petting in sports, etc. Right, let's talk about airbags and seat belts in motor vehicles. Airbags and seat belts extend or increase the time required to stop the momentum of the driver. Right, remember, let's say the car is moving at 120 kilometers per hour and then it collides with another car or collides with something else like this. Okay, what will happen to the driver? The driver will continue moving at that same velocity until maybe stopped by the steering wheel or the dashboard or something, or the windscreen. According to the Newton's first law of motion, remember that a body will remain in its state of rest or motion at constant velocity unless a non-zero net force acts on it. So when the car collides, the driver will continue in its state of motion until it hits the dashboard. So what does the airbag do? When the airbag is inflated, the driver is prevented from moving forward at a faster rate. So the time is extended. The time of impact becomes longer. This decreases the net force and injuries are reduced. We're not saying that the injuries are not going to be there, okay, but they are reduced. That's why it is advisable to wear your seatbelts and make sure that your airbags are functioning. Crumple zones. When cars collide and crumple, the time of impact is increased. Look at this part here. So the time of impact is increased. So this acts like an airbag somehow, or acts like a sponge, right? So it increases the time of impact. So when the time is increased, then the net force is decreased because these two quantities are inversely proportional. Petting in sports. Petting is slightly compressible. During collision, time of impact is increased, thereby reducing the effect of the force. When time is increased, F net is decreased. Another good example, remember high jump. Talk of high jump, right? And then someone will land where? When they jump, they land on the sponge, right? So what does this sponge do? It increases the time of impact. And then the athlete will not get injured when he or she lands on the sponge. But just imagine if the sponge was not there and someone hits on the ground. The time of impact is greatly reduced. And then when the time of impact is reduced, the force is what is increased. Remember, net force and time are inversely proportional. If the time is very small, then the net force is very high. Arrestor beds on roads. Arrestor beds are patches of ground that are softer than the roads. So it's softer parts of the road or patches of the ground that are softer than the roads, right? When a truck reaches an arrestor bed, the time interval on which the momentum is changed is extended. So the time interval is extended. This decreases the net force and the trucks slow down. These are some of the applications of impulse in safety considerations. We cannot exhaust all of them. These ones that we've discussed will give us an idea about the impact of impulse in our safety.